Okay, let's go ahead and get started with 6.4, writing inequalities given a graph. Now, the first two I am going to break up into a lot smaller pieces, and then we are going to put everything together. And then on example 3, I will do all of that one as if I was just looking at it as a new problem, okay? So first off, we need to remember what slope-intercept form are, point-slope form, and standard form. And then remember that when we're in standard form, a has to be a positive number, and there can be no fractions. Now, when we are writing these linear inequalities, we need a lot of pieces of information, okay? So the very first one we're going to be looking at is whether this is a dashed line or a solid line when I look at the linear graph. Now I'm going to say ignore the shading here for just a second, but on this one here, is it a solid line or a dashed line? This one here is a dashed line. By that I mean it is broken up into smaller chunks here, not a whole solid line, okay? The next thing I'm going to look for is the y-intercept. Well, here's the y-intercept. And remember, we wrote the y-intercept in two different forms. We wrote it as an ordered pair so that it's 0, -4. And we also said we could say that b equals -4. All right, now the next thing I want to look for is the shading. Is it shading above or below the y-intercept? So if I was looking here and drew a down arrow or drew an up arrow from that point, really, I could do that from any point on the line, okay? Any point. Is it shaded above or is it shaded below? And we can see that this one is shaded below, so that means that this one will be y is less than whatever our equation of the line is. Now, if it was a solid line, it would be less than and equal to, but this one is not equal to because it is a dashed line. So the last piece that I need to look for is I need to look for the slope. Now, to find the slope, we are going to find 2 points on the graph, and then we are going to count the rise over the run. We already have 1 point, that's the y-intercept. There are several points on this line, okay? So if I was looking, I could say that this is a good point to graph or to count rise over run. This one here would be a good point to count rise over run. This would be a good point. There's a lot of good points to pick from. However, I only need 2. So whichever 2 you see are the 2 that I want you to use. No matter which 2 you pick, our slope should always come out the same because we are all measuring the slope of the same line. Now, oftentimes I will look to see if the y-intercept is a nice point and if the x-intercept are a nice point. If they are, I'm going to use those 2 points to count my rise over run. Now, on the worksheet, these might not show up as well, but I did notice that the numbers here told me that this went up by 2, that went up by 4. So the rise is up 4, the run went right 2. So for the slope, rise is what goes in the numerator, run is what goes in the denominator. Since it went up, that's +4. Since it went right, that's +2. And that reduces to 2. So now we have all the pieces that I need. I have the y-intercept, I have the slope, I have whether it's solid or dashed, and I have that y is less than, the shaded area is less than the line, okay? So when I go to write this out as an equation in slope-intercept form, I have y is less than 2x minus 4. Now remember, slope-intercept form is this one here. Okay, I'm going to come back to standard form here in just a second, but I want to go on and work on another one doing this exact same process. All right, so here we go. On this one here, I'm going to find those same 4 pieces. On this one, I notice that this is a solid line. There's no breaks in it. Again, I'm not paying attention to the shading right now. I'm just paying attention to our linear graph. So then this one here is a solid line. On this one, it is a y-intercept of 0, 4, or we can say b equals 4. I notice that it is shaded above, so when it's shaded above the y-intercept, that is going to be y is greater than. It's also a solid line, which means it's included, so y is greater than or equal to. Now, the last thing I need to do is find the slope. Now, the slope, find any 2 points that you can recognize on the line that we can use to count rise over run. Okay, it can be any of them. Again, I like to look for the y-intercept and the x-intercept. However, some people said, hey, I see this one here. And that's true, and that's a lot closer. So on this one, to get from the first point to the second point, went up 1, right 1. So the slope on this one, rise 1, run 1, which is just 1. Okay. Now, what if we would have picked different points? So let's try that. What if I would have picked the x and the y-intercept? Okay. What if I would have said, this is my y-intercept. X-intercept I can also use because it's not a fraction or a decimal. How many do we rise? 1, 2, 3, 4. So in that case, our slope would have been 4 for rise, and then 1, 2, 3, 4 for the run, and 4 divided by 4 still gives me 1. So again, the points that you select, as long as our slopes come out the same, we're going to be okay. Now, to write this in slope-intercept form, we have all the pieces that we need. I've got y is greater than or equal to, and that's because it's shaded above the linear line, the linear graph. Y is greater than or equal to. Our slope is 1x, and our y-intercept is positive 4. So y is greater than or equal to x plus 4. Okay? So those are the 2 things that I want you guys to think about when you're looking for these. So like I said, we're going to look for solid or dashed. That's important. We are going to look for the y-intercept. We're going to look for the slope, which is the rise over run. And then we're going to look for where is it shaded, above or below. Okay. All right. Now, once I have those pieces, I can write the equation in slope-intercept form. Now, from slope-intercept form, we are going to convert to standard form. So from this form here, we are converting to this form here. Now, remember, A has to be positive, and there can be no fractions. Okay? So I'm going to rewrite our equation here. So I have y is less than 2x minus 4. The first thing I'm going to do is move 2x to the other side. So I'll have negative 2x plus y is less than negative 4. Now, a cannot be negative, and it's currently negative 2. So what I'm going to do is multiply it by a negative, or you could say negative 1. I'm going to distribute that negative 1 to everything because everything is in the parentheses. Negative 1 times negative 2x is 2x. Negative 1 times y is negative y. Because we are multiplying or dividing by a negative number, we are going to reverse the inequality. Negative 1 times negative 4 gives me positive 4. And then our equation is in standard form. Okay? All right, let's go do that second part for the second example here. So our equation is y is less than or equal to x plus 4. So I'm going to take this x and move it to the opposite side of the inequality. So I'll have negative x plus y is less than or equal to 4. Now, because that's a negative x, I'm going to multiply the entire equation by negative, or you can say negative 1. Negative times negative x gives me x. Negative times negative y is negative y. Negative times a greater than or equal to is now going to become less than or equal to. And negative 1 times 4 gives me negative 4. Okay? All right, so let's go over this last example and see how quickly we can do this without using all the little pieces that we have to write down, but seeing how we know to start this. So on this one here, I need to know the y-intercept. The y-intercept is b equals 2, or you can write it as 0, 2. Okay. To find the slope, we're going to find any 2 points. I'm going to pick this one here. We're going to count the rise over run. So this one is going to go down 2, right 2. So the slope on this one is 2 over 2, which gives me 1. Then I know that it's shaded below, so that's going to be y is less than. It's a dashed line, so it's not going to be equal to. Now when I go over to write my equation, y is less than 1x plus 2. Or we can just say y is less than x plus 2. Now to write that in standard form, we're going to move x to the other side of the inequality by inverse operations. So I'll have negative x plus y is less than 2. Multiply everything by a negative, so that'll give me x minus y is greater than negative 2. Okay, so your examples that were for homework are on the back side of this worksheet, doing those exact same things. We will get back to you checking that solution of 0, 0 for each inequality, but right now we were just working on this first step.